Hello and welcome to the 18th topic in this course. We're looking at the internet today, following straight on from last video, which was talking about networks. So specifically we're looking at the internet. The internet is just a network. It's actually a worldwide collection of computer networks. That's a proper definition. So I would definitely say, if you haven't watched the previous video, definitely watch it, because although it's 25 minutes, there's so much information that relates directly to what I'm talking about. In today's video, it's crucial, in my opinion. So first of all, I showed a similar diagram for the last video, but this is more how you could actually connect a LAN to the internet. So you have your individual LAN here, and then this LAN is connected to a router. This is actually a wireless router. You can see you have these waves coming out. This is how wireless works. So you have your router here, and the router may be connected to a modem. And we'll look at what this is in both of them in a minute. But then the modem's connected directly to the internet. So I've used different colours here because this is probably Ethernet cables, and this may be a telephone line. That's what a modem partly does. So the internet is this massive network that's comprised of all these different little networks. And in my head, this looked really good, but it doesn't look so good now. I'm looking at it now. So you have all these little networks. Some are bigger than others. Some will be massive, like the World Wide Web, which is a huge portion of the internet, which is, web pages. We'll look at that a bit later. And you also have bits like the deep web. You have online gaming, you have peer-to-peer networks, you have DNS server networks. Again, we'll look at that in a minute. So first of all, looking in more detail about the two bits of hardware I mentioned. First of all, a modem. So you may not know what a modem is. You probably have one in your house. You may not even realise you do. It's just a box, maybe sits next to your router. So modem is actually, it's one of those words a bit like bit, binary digit. It's two words combined. So the words that combined are modulation and demodulation. Now, that's basically saying what it does. It doesn't really make sense, those two words, if you don't know what they mean. But what they basically do, they convert digital data from your computer into analog data if it's transmitted along telephone lines. So what it does, there's different types of modem. A modem is quite a general term, but a cable modem is basically just used to connect a network to a nearby telephone line that maybe runs under your road, or maybe above ground, depending on where you live. And that goes straight to your ISP, your internet service provider, Virgin, BT, etc. And it just converts digital data from your computer into analog data. So hopefully you know the difference. We looked at this very early on, I think. Digital data is ones and zeros in binary. Analog data is slightly broader. They're like waves. So waves, so probably sound waves down telephone lines. And it's just different types of data that a modem converts between. And they're the actual the devices that provide direct access to the internet, usually via your internet service provider. And this is what a picture looks like. Doesn't really matter what they look like. Just a box with some lights on it. Doesn't actually really matter. So a router, I did define some last video because I thought it made sense, but I might as well repeat it and maybe give a slightly better definition, because I was a bit unsure. I was maybe a bit relaxed when I was defining it last video. So a router basically forwards data packets. We looked at this last video, but a data packet is just a bit of data that's been decomposed from a bigger section of data, just so it travels in individual packets. And a router forwards these packets to make sure they reach their destination. So if you're sending a packet to another computer across the internet, it makes sure that it reaches that destination, and they pass the data through the different networks that comprise the internet. And the actual technical term, I don't think you need to know this, but the packets hop between routers. It doesn't sound like a real technical term, but it actually is. That's what you call it, hopping. We've got a diagram here. We're going from a workstation across to a router. It hops between the routers. And so a router basically connects to other routers. It connects to loads of routers until it reaches the destination. So a router isn't working on its own. It's working with other routers to connect this sort of web between computers and networks. And another important function of a router is that it doesn't just forward packets. It makes sure they get to their destination. A router is useless if it doesn't make sure it gets to its destination. For example, if a router if this router 1 was trying to get to router 2 and this cable broke, it wouldn't just give up. It would find another way to get around. Maybe there'd be a third router somewhere. Probably millions of billions of routers, but anyway. Also, routers make sure that the data is sent only to the places they're needed. It doesn't just send all the data everywhere, because that would just clog up all the networks and make the internet be a lot slower than it is. Okay, so I just want to be quite clear about this because perhaps I was being a bit relaxed when I was defining it. We were talking about switches and hubs last video, which are more to do with like in networks as opposed to lots of networks together. So what a router does, it receives and sends packets between the networks, whereas a hub or switch basically, among other things, receives and sends packets over one network. So they're sort of quite different in that one is over a broader area, one's in one network, but they do different things also, but I wanted to be a bit clear on that one. Right, let's move on to looking at IP addresses in more detail. We defined what an IP address is in the last video. So just to recap, every device connected to the internet has its own unique internet protocol address, and this IP address is used in order to send and receive data. It's like an address on a letter. And so, like I mentioned, I alluded to earlier, a massive portion of the internet is the World Wide Web, and that consists of basically linked web pages. Linked web pages, and Tim Berners-Lee is actually the inventor of the World Wide Web. You don't need to know this clearly, but I think it's good knowledge. If you're doing this subject, you need to know one of the key forefathers of this. So he invented the World Wide Web. If you ever go to CERN in Switzerland, he worked for CERN. He was at CERN when he invented it, and he still has some of the documents and the first proposals there. And he was the one who proposed some protocols, and he was the one who linked it together with HTML, which we'll look at in a minute or two. So he was the inventor of the World Wide Web, and we have something called the Domain Name System, DNS, and that's what links IP addresses and web pages together. So we have our domain names on our website, so iTunes.com, Google.com, and that's its domain name, and it also has an IP address, and the computer needs the IP address in order to connect to it. And the protocols that govern DNS are in the TCP/IP suite, the Internet Protocol Suite. And what DNS does, it translates this IP address, which is just a number, into a domain name. You wouldn't want to type this into your browser every time you want to connect to Google. This is actually one of the many IP addresses Google has. So if you actually type this into your browser, Google will actually come up. But instead, you really want to be typing in an actual recognizable name. And DNS links the two together. So basically what happens is, we'll look at this in more detail in a second. Instead of doing this very simple process, it goes straight to the website. You connect to what's known as a DNS server, Domain Name System Server. And this server looks up the IP address of the website, the domain name, and sends it back to your client, your computer, which then can connect to the website. And if we look at that in more detail, we'll look at DNS servers. So these just contain a massive database. So you have millions of them worldwide. Some are massive. You have called root DNS servers, which contain all the IP addresses in the internet, and they sort of trickle downwards to smaller and smaller servers each time. And so basically you have this global database contained with individual servers of IP addresses and domain names. And so they operate in their own network, a client-server network, as we looked at in the last video. So if we just do a flowchart, I don't know if this flowchart is like correct as in you're supposed to do it, but hopefully it just illustrates what I'm talking about. So first of all, you have your user that requests a website. So we're going to talk about Google. So you have your user that requests a website. It connects to the server, a DNS server, and the question the DNS server asks itself is the IP address is the Google IP address in its database? And if the answer is no, it loops around till it connects to another server. So at this point, it acts as a DNS client and connects to another DNS server. So you have this network of actual servers, DNS servers connected together, and they ask each other. They'll keep asking each other until they find the IP address for your domain name. So this is just like a client-server network, a typical client-server network, except the DNS servers can act as both clients and servers. And if as soon as you find a DNS server that has the IP address, it then sends it back to your client, your original client, which is usually a web browser, and then you can contact the actual domain name server. So Google will have servers as well, and you can connect to that. Incidentally, Google also do have their own DNS servers, so anyone can have a DNS server. If you hold a website, occasionally people will want their own DNS server just out of like a hobby sort of thing. So I don't totally understand, but then This is your own choice, but often massive businesses will have their own DNS servers like Google do, and like I said, there's some root servers that are just huge. So anyway, I'm not going to read all of this. Maybe if you want to pause the video and read it, that might help. I'm going to move on to looking at HTML, and this stands for Hypertext Markup Language, and this is all to do with the World Wide Web. And we mentioned that the World Wide Web is a linked collection of web pages, and HTML is the language used to create web pages. And a key distinction is that HTML is not a programming language. It's called a markup language. It's in the name. Make sure you know the name, by the way. I've seen exam questions where they actually ask you for stuff like this, what it actually means. So it's a markup language. A markup language means that it presents data. A programming language actually does something to data, it transforms it, whereas a markup language just presents it. So what happens is web browsers read and interpret HTML code to present it visually to anyone viewing it. So you have this HTML code here. I just wrote it in Notepad. You can use Notepad to write HTML code. I recommend, if you're interested, look up some tutorials for it. You can create your own web page very quickly. So you have your web browsers. So one of these web browsers will read and interpret this HTML code. HTML uses tags. So you can see here we've got tags that signal certain things. So we have this ones that signal for main body, you have ones that signal paragraphs and headings, and the web browsers read the tags and they ignore them. They present what's inside the tags to the user, and then instead of this code you see this web page heading and paragraph. Such a boring website, but that's a really simple bit of HTML code, and HTML is pretty boring on its own, so you use something called CSS and Flash, JavaScript to add some more functionality to your website. So HTML is currently managed by the World Wide Web Consortium, which Tim Berners-Lee, I think he might be chairman of, something like that, and it's currently in version 5, HTML5, and there is issues with compatibility because old browsers, if you went on a computer 10 years old, it wouldn't be compatible with version 5 most likely, but all browsers will follow at least one of these 5 standards, meaning that you have to be a bit careful. You have, if you actually do a proper website, this is just locally held a HTML file. If you actually put a website on the actual internet, you would usually write a line of code saying which standard you're using, just so compatibility isn't such an issue. Maybe that's stretching things a little bit. Okay, finally we've got to look at compression. And compression, if you want to define it, is a reduction of a file's physical size so that it contains less bits of data. When I'm talking about bits of data, you've got to be careful. I'm talking about bits as in zeros and ones, binary data that represents a file. So reason why compression is important, especially in the internet context, you have all this data packets being transmitted over the internet, and often you pay for the amount of data you send and receive. Nowadays it isn't so much because often you have unlimited. Well, I use unlimited a bit loosely because you have some kind of cap. If you're using on your phone, the data you're downloading is going to cost you money most likely, unless you're using Wi-Fi. So it means that if you compress a file so that it's smaller, less bits of data, and I'm using literally bits of data, gets transmitted to you, so you pay less, which is quite a big advantage really. And also if you're talking about servers, if data is held on servers and it's smaller, it's more cost effective for them as well. Also, another quite simple advantage to compression is that it takes less time to download. The less data you have to download, the quicker it will be to access a file. Hopefully that's quite self-explanatory. So we're going to look at 2 types of compression. The first of which is lossy compression. And lossy compression, in this type of compression, some of the original data is removed during compression in order to reduce the size. So here you have actual data being removed from the compression. So some data is lost, meaning that after it's uncompressed, after being compressed, the file isn't the same as before. Often if you're doing an image or music, it will be of lower quality, although clearly they try and make sure that the quality isn't affected as much. As in with music, we'll look at in a sec because we're looking at some file types. They basically just remove the stuff that you won't hear like really high frequencies and things. You have another type of compression, is sort of the opposite. You have lossless compression, and hence the name. This sort of means that no data is lost. But it wouldn't be compression if it didn't shrink for physical size. So what happens is the storage is made more efficient. So an example, again, this is in my head, this looked really good. It may not look that good in reality, but if you have, this could be like a line of an image. We looked at how images were represented ages ago, but we have these pixels, different colours, and if this image undertakes lossless compression, it gets shrunk basically. And you can see here we've got 2 lots of repeated pixels. So we've got 4 purples and 2 oranges. We've got 1 orange here, but there's no point. You can't really compress 1 pixel. And here you can see we've basically just shrunk it. So we've made a note that we had 2 oranges here and 4 purples, and it means that less data has to be transmitted. So you save on data here. So yeah, the individual pixels are grouped to save storage space. And this means that we actually, after you uncompress a compressed file, the data is the same. Nothing's been lost. It's just been sort of rearranged and made more organised. So that's obviously quite a big advantage, although lossy compression is usually a lot more effective. So finally, the last thing we need to do in this quite long video, I'm looking at file standards. So these are more sort of what you'd associate with like file names. So first of which we're looking at JPEG. So JPEG, and this uses lossy compression, meaning that data is lost, as we just looked at, and it stands for Joint Photographic Experts Group. I doubt you need to know that. They just created it, and it's mainly used just for images. And I've shamelessly taken this from Wikipedia. This is really cool. Actually, it's a picture of a cat, and you can see from right to left the actual amount of compression is being reduced. So here there's barely any compression, the quality is quite good, but at the left you can see massive compression, lots of data is being removed here. So the file will be a lot smaller if it's all like this, but clearly the quality is being compromised. So I thought it serves as quite a good example. Also you have GIF. Anyway, you have GIF, and that stands for Graphics Interchange Format. People pronounce it GIF or GIF. I think you're meant to pronounce it GIF, but I've never called it that. And a GIF is a single image. It can be a single image, or it can be lots in succession, and it is not very good. It's very old technology. It's like 20 years old, and it only uses a maximum of 256 colours, which really isn't that much, and that often means that you have one set of 256 colours per frame, meaning that every frame uses the same set of colours, which means it's really not that good for videos. It's really good for simple animations. I mean, I've chosen this not least because it's for Simpsons, but also because if you can see, you have some sort of loss in quality here, because that's not due to compression, because this is actually lossless compression. No data has been deleted, but it's not really optimized for video. Whatever the Simpsons animators did this in is obviously a lot better. The frame rate's a lot better. I mean, you have some sort of loss of quality here, even though it's lossless compression. So next we have a PDF, and this stands for Portable Document Format, and this is usually just a read-only file designed that you can view it on those devices. It doesn't have many compatibility issues, but you can edit it obviously, but mainly you'll be reading it only. Penultimately you have MP3 or MPEG-2. I think it shares very similar to technology to MPEG, and yeah, so MP3 is used for audio files, and it uses lossy data compression, so it deletes some of the audio, but usually the audio they choose to delete, the algorithms choose to delete, is stuff that you won't really notice so much, although depending on how extreme the compression is, the audio quality may drop. Finally, MPEG is, like I say, a version of MP3 mainly for videos, but also uses lossy data compression. And what it does, so the video watching this on is on MPEG, and what it does, in these frames, the background here isn't changing for each frame. This is changing, my mouse is changing, and instead of, it won't repeat pixels, it won't store pixels again each time if it's being repeated. It basically will treat this as an image for however long it doesn't move for, sort of thing. So it doesn't delete data, but it just makes it more efficient like that. Okay, so that's it. We're looking at algorithms next, but hopefully this video was useful. And yeah, hopefully I'll see you in the next video.